Hey everyone! So, my lesson will be about limits and continuity, aka probably the best calculus lesson that you will ever learn. But I guess maybe differentiation too. I guess. Right, okay, so first things first, we always have to consider the fact that there are two ways to solving math problems. And this can be solving things graphically or solving things algebraically. So let's start off with this first question that involves limits. Spoiler alert, the answer is B. But why? Well, if we look at option 1, we notice that there is more than 1 point. Strange, right? We'll learn more about this when we get to continuities, but if we go on to option 3, there's the same issue since 4 has two different values coming from each side. So as it approaches it from the left, it equals 4, but while it approaches it from the right, the y-axis would then be equal to 1. So there's that same issue right there, and as a result, we can't identify the limit as x approaches 4 on this one either. Now, doing process of elimination, we can conclude that option 2 is our best option. Alright, so this is the next and last question to make things faster. I chose to pick a problem that involved both continuity and differentiation. So before we answer this, we need to understand that continuity just means where a point is defined. That's all. So in this example, if f of 5 equals 3, that means that x is continuous at x equals 5. And always remember that the point must be filled in. It has to be a little black point. It can never be like that white or transparent one, however you want to call it. So now if we go back to that limits problem from earlier, we can see that they also have these unfilled points right here. And that is the quickest way to determine continuity or discontinuity. So 1 and 2 are removable discontinuities, and that's because if you fill in that little point they have right there, it would just be continuous like that. It would make sense. While as option 3, for instance, it's in its own little universe because even if you fill in that point, that doesn't change the fact that one is going one way and the other another. We call these jump discontinuities because one is jumping on top of another one. And these are, as you may predict already, non-removable. So now that we know this, and we go back to the problem, the only letters that don't have this empty point are A, C, and E. But now the question is asking, where is it not differentiable? Well, what does that mean? Well, differentiation is synonymous to your derivative and also your slope. They're triplets because they literally all have the same meaning. So to not be differentiable just means to have an undefined slope at a point. So you see how right here that sharp point creates trouble for us? Like, you may not be able to tell right now, but let's compare it to the well-known quadratic function. So we all know its derivative is a linear function, and you see how more smoothly that's getting? That's what we want. In conclusion, a function with a very harsh and spiky point like this one is not going to be differentiable. And this is an absolute value function right here, for example. So now knowing this, what's the answer going to be? Yes, right. The answer is A. You did it! Well, that's pretty much all I have. I hope you learned something today, or you at least enjoyed the video. And yeah, thank you for watching.